Have you? Okay. Yeah, let's do it.
All right, everybody ice creamed out and ready to go? We all scream for ice cream. Yeah. Well, everybody's streaming in. I get the pleasure to introduce Paul Coggin. I call him Bubba. He is actually a very, very good friend of mine. I got to meet him a couple years ago at another con, and we sat there forever. And I realized I know nothing about networks after I talked to this guy. And so we get to speak at each other's cons all the time. Paul is an internal network consultant solutions architect for Dianetics down in Huntsville, Alabama. He is nicknamed for us, we call him Mr. IP. If we have a question about networking, this is the man to ask. He's a man of very few words, and so the introduction will be very few words, but please give a big hand to my good friend and network expert, Paul Coggin.
Thanks, Dave. I really appreciate Parameter letting me be a part of ShowMeCon again this year. We had a blast last year, and this year's been unreal. Just another great conference, meeting a lot of really great people, listening to some good talks. So I'm the router guy at a lot of these conferences. My expertise is telco service provider, critical infrastructure, utilities. Got an interest in SCADA. So what I'm going to get into in this talk is whenever I work with a red team, some of the roles I do before I jump into the red team is I do design, implementation of secure networks, and I try to break into networks that you're supposed to not be able to break into in the telco service provider critical infrastructure realm. And this talk was developed as a result of me working on some red teams with pen test teams who were very, very, very talented. And we'd get shells everywhere, and then we'd get into routers, and the guys didn't know what to do with the routers. And so this talk is, if you're in a red team, this is going to give you some ideas next time you go get into somebody's router, some cool stuff that you might want to consider doing if it's inside the rules of engagement for the contract that you're working under. So how are you going to get the initial access to the router? I typically focus on the network management infrastructure, finding some way to exploit trust relationships, exploit some network guy that you find on LinkedIn to go after, so that you can discover how they do network management. But one way that you might go and get into the network is you've discovered through your recon information gathering, you've come across information that leads you to understand the specific host that the network on the right here I have represented is. You discover the systems that are trusted. Say there's SolarWinds, there's Cisco Works, there's HP OpenView. You discover what that IP address is, but the network guy, he's been through all the training. He's Juniper trained, he's Cisco trained, etc. He knows how to put access list on his router and secure SNMP remote access. Well, what you might do in that case is you could go and download this script called SNMP Blow that allows you to specify the IP address of the network management system that is trusted, specify the IP address of the targeted network device, whether it's the router or switch, and specify the IP address of your TFTP server that you're running to launch an attack against this customer. And at the same time, because you've done a really good job of information gathering and recon in the initial phases of the engagement, you've built a dictionary of keywords based on the organization or the personality that you've discovered. And you can combine your dictionary with the IP addresses I just mentioned, the network management IP, the target, and your TFTP, combine that together, and SNMP below will go and fire UDP SNMP packets at the network device until it guesses that SNMP community string, which is basically the password for SNMP. And if you've guessed the password in your dictionary, then you're going to, with this script, you would download the config, and then when you download the config, you can discover SNMP community strings that you already had discovered, but you would get passwords and get other intel about that network device. And then because you've got all that intel, then you could go upload a new config, upload new code, etc. So this is a way that you might get the initial access to the network. We're going to focus now more on what to do after you've gotten access to the network. So what can you do with a router? You've popped boxes, you've got a Metasploit, you got some shells on some Windows boxes, Unix boxes. You found, say, maybe a TFTP directory that has some configs archived in it, and you've gone and gotten access to the routers. And so what do you do besides take a screenshot and document the fact that you've logged into somebody's router and downloaded their configs? What else can you do with it to take over the whole network architecture for that organization? Well, one thing you can do is you've been through any kind of hacking training, and one of the first things you learn is ARP poison with Ettercap and Cain and Abel, some old school stuff you learn in the first day of a hacking class. Well, instead of just doing the typical layer 2 man-in-the-middle attacks, one thing you could do is if you say we pop that box down there in the center and bottom, that layer 3 switch, if we assume that's a Cisco router, Cisco switch, there's a capability called route maps that enable policy routing. So we could go and do what I figured out is a layer 3 man-in-the-middle attack where we can cross VLANs. The stuff what you typically learn in your hacking classes is how to go do the layer 2 just inside a single VLAN. But if you go and you pop a router and you want to go be able to do man-in-the-middle attacks to say capture passwords of inter-VLAN traffic, we can go and create an access list to specify the traffic that is of interest to us, associate that with a route map, and implement policy routing on the interfaces that are of interest to us, and force traffic based on the access list that we define, and force traffic to cross additional VLANs to, say, the system that is of interest to us, so where we may have influence, say where we have an attacking system, so that we can sniff traffic, modify and inject traffic, et cetera, whatever, and then forward the traffic back to where it was originally destined to, and enable a layer 3 man-in-the-middle attack. Or we might be able to go and override the routing table using the policy routing, override the default routing table, and it doesn't matter if you're using static routes, OSPF, GRP, what have you, for an internal routing protocol. When you implement these policy routes, it is going to override the routing table. The routing table may say force traffic one way, but when you do the policy routing with the access list you define, you're going to override that and send the traffic a totally different route. And so we could go and do that same thing and force it to go out, say, a backdoor 4G router connection, or we can move up to the perimeter and say if you have a more complex scenario where you got a customer that you're under signed legal authorization to be hacking, you might go and force traffic out one of the paths that's going to lead more to a data center someplace in the cloud where you have more influence. This specifically might happen if you have an adversary grab a hold of your network where you're multi-homed and want to go and direct traffic out a certain WAN path. That's where you're probably going to see that more at the perimeter. But down in those lower 2 layers, that's going to be something you might do as a part of a red team where you override traffic and force it out a back door. So another thing is I started thinking about what could you do as a part of a red team to networks. It's very well documented. If you go and take some of the more advanced pen test classes, or if you're an old router guy like me that's been around and got schooled in running legacy protocols like IPX, DECnet, AppleTalk, etc. over GRE, IP tunnels, you might know about this, but one of the things you can do with a router, and it's very well documented in this Symantec white paper here, is you can build a GRE tunnel so that you can again, use a route map and do policy routing, and from your router that you own, you can create a GRE tunnel to the router that you may have popped, and in using route maps, you can go and enforce traffic that you specify that is of interest to you, force it across that tunnel so that you can sniff it and analyze it. Well, this is very well documented and very well known, but I started thinking as a router guy, here's another technique that people have not thought about, I haven't seen published anywhere, is there's a new capability for sniffing networks in Cisco routers. It's not brand new, but it's new to many people, and it's not been documented in regards to security yet, is you could use ER span. You guys are familiar with doing port mirroring, span port on one single switch, doing R span across multiple switches. With ER span, it's designed to mirror ports over a wide area network. Well, if you were involved in a red team engagement doing pen testing, and you crack open, you bust somebody's layer 3 switch, their router, one of the things that you might want to do to them, if there's a network specific interest to you, you wouldn't want to do it against a high volume traffic VLAN, but like if you're into a SCADA network, some other kind of control system network, some network that's got some sensitive, interesting traffic that is not huge volume, you might want to go and do an ER span, and you can mirror out traffic across a wide area network back to a point where you have sniffing capabilities so that you can analyze traffic and gain further intel on your adversary, whoever you're going after. And so along those same lines, what you can do with a router, back in the late 90s, I got involved with SNA, built out a wide area network using frame relay and SDLC controllers, basically green screen terminals tying back to a AS400. And what we would do is we would take the IBM SDLC protocol and SNA networks, and we would tie specifically SDLC controllers into the router using a serial connection, and we would with DLSW, which is a tunneling protocol, we would tunnel the SDLC SNA type traffic across an IP backbone. And what happens is, you see here in the config down at the very bottom, is we're bridging. And how things work with a router is if you turn on routing for a protocol, it's going to route it. But if you have routing turned on and you have bridging turned on at the same time, if it's not routed, if it's not a routed protocol that you specified to route, like IP version 4, and you have like NetBEUI, IPX, SNA, etc., and you have bridging turned on, it will bridge those protocols. Well, what I started thinking about that, IPv6 is a totally separate protocol. It's IPv4 and IPv6 are totally separate protocols. And if you do not go and turn on IPv6 routing and you turn on bridging, it's going to bridge IPv6 even though you have an IPv4 backbone. And so what I figured out is part of Red Team is one of the things that you might want to go do is turn on IPv6, and if the router has DLSW feature sets on it, so that it will support the DLSW command set, and it will if it has IP plus or better iOS software running on the router, you have the DLSW commands, and then you can go ahead and turn on bridging and not affect their IPv4 routing and bridge IPv6 out across their wide area network. And most likely the target that you're doing a pen test against, they'll never know that it's happening. Because what I discovered 9 times out of 10 is whenever we go and gain access to the router, we have never, ever been discovered. If you can get a hold of the routers and you can start influencing the network, most likely they're never going to discover it until you've given them a report and notify them. And so this is something that you might do with IPv6. It's not documented anywhere. It's not supported. It's not the RFCs for DLSW. They specify specifically they support SNA and NetBEUI, NetBIOS rather. But this is something else that you could do. You could go and run IPv6 across it. It's just something cool that you can do. Why not, right? Makes for an interesting conversation. So I work in the telco world, and one of the things that we do in the telco world is we do a lot of tunneling of PPPoE across wide area networks. And typically, most networks I use MPLS, Ethernet over MPLS, to tunnel protocols. But one of the capabilities that's out there is called L2TPv3. And what the L2TPv3 does, and this just like EO-MPLS, Ethernet over MPLS will do, is there's a concept called a pseudo wire where you can go and drag and drop a logical wire across a wide area network. So you can take a VLAN that's on one side of the world and drag and drop it over on the other side of the world and cross X number of routers. Even though you're crossing all these layer 3 hops, you can make it look like one big layer 2 connection across the network. And you can do that with L2TPv3. And what the telco service providers will do, they'll use this, say like an AOL. They might go and use a wholesale DLS service from, say, Quest, AT&T, etc., and they will go and use their DSL modems that they provide you and backhaul your PPP connection from home across, say, AT&T's routed internet network and terminate it at their router, which they call at their place a BRAS, a broadband remote access server, which is nothing but a router. But when you're talking to broadband telco service providers, they call it a BRAS when they're aggregating that subscriber traffic. And they will aggregate all of that layer 2 traffic that's been tunneled across the internet at their router. And that got me thinking, since you could go and build this layer 2 tunnel across all these router hops, what could you do with that? Now, the current information that I'm doing my research, when it comes to L2TPv3 and security, there's a good paper out there that a gentleman wrote where he focuses on L2TPv3 in the telco service provider infrastructure, attacking the control plane of the protocol as it goes across the telco infrastructure. But what I want to make you think about is on the endpoints inside the user network. What can you do with L2TPv3 in the user network? And basically, just like GRE, you can go and tunnel across a wide area network and use L2TPv3. And most of the times when you go and pop a router, very well could be that they have the feature set to support L2TPv3 to enable you to do a pseudo wire connection across the wide area network so that you could go and do other layer 2 type attacks to the network. And if you find yourself with access to the router and they don't support any of these commands, since you have the access to the router, just go and upload some new code if the code that you have access to doesn't support it. Go and escalate your privilege. Upload new code so that you can go and launch an attack like this. There's no reason you couldn't go and do all the different layer 2 attacks across that connection as well. There's a lot of talk these days about CLIA, Patriot Act, things like that. But this is how kind of the architecture Cisco has laid out for Lawful Intercept, and this is how you would do a IP-based wiretap. The telco service providers are required legally to have this type of infrastructure in place so that when law enforcement serves papers to them, that they can go and do a wiretap against whoever they're interested in traffic for. And what that happens is the law enforcement can communicate to a device that's typically in the network that they can go talk, that they can send commands to, and they can go and talk to the network infrastructure and be able to go and get a perfect copy of all traffic that is of interest to them sent to the law enforcement. And what happens is the bad guys are talking and a perfect copy of what the bad guys are talking about is being sent to law enforcement. And that happens, and how that is supported with the Cisco stuff is through SNMP-v3. But what I want to call out to you something about what happens with the telcos, how we provide this and make sure that when an IP traffic stream is being captured, how they know that they're getting the right person. If they're not doing PPOE with radius authentication, where a user is being tied down to a specific address by way of their user account password with PPOE and radius, what will happen is they may be doing DHCP, which is what we're rolling out typically today. How you do that with DHCP is with a capability called Option 82. And I wanted to call that out for a lot of you enterprise guys that struggle with DHCP, and you want to be able to track down specifically, physically where some user is coming from that's doing DHCP, especially in very large VLANs where you got really large IP segments and you're having trouble tracking down across a building or a campus because of how you got your VLANs locked out. You're trying to find where that guy's coming from. With DHCP option 82, whenever your user sends out that DHCP request, you turn on DHCP snooping on your Cisco devices. That switch sees that DHCP request. It injects in the packet header for DHCP. It injects in the chassis name and the physical port number that request is coming from. And then if your DHCP server supports it, it will log it. And then you can track it back to where that IP is being sourced from. We use it in the telco world at the DSLAMs and the different broadband devices, like the fiber to the home devices we might be aggregating your traffic with, so that we can make sure that the right address is being tracked. But from a red team standpoint, if you pop a router, one of the things you might want to consider when you're doing an attack strategy, I like to do attack trees and draw out how, if I get certain levels of access, what I'm going to do with it, depending on what the rules of engagement are. One of the things you might want to consider is doing this lawful intercept attack to show the users that you're able to attack the router and they have their normal line of communication, and you define an access list and exploit and utilize the lawful intercept capability that might be in the router and get a perfect mirror copy of all the traffic that is of interest to you. Now, it may be, in this case specifically, that you may not have the feature set on your router to support this, but if they have the flash memory and the DRAM, you could just upgrade the code and give yourself this capability. It's something else to consider. Put it on the table. Here's a scenario went down where we were doing a pen test against some critical infrastructure. Have an organization. They have a head end. Basically, a head end is a cable TV head end. If you're an enterprise, it's a data center. If you're a telco, they call it a central office. Depends on what the organization you are talking about. So they got a head end, and they've got all this new IPTV equipment, encoders, etc., up here on the right. And then they've got their network infrastructure that goes out to the field where they provide services to their customers. But in this case, what you have up there in the upper left-hand corner is you have say a cloud-based provider. You have somebody that's providing IPTV services, basically cable TV over IP services, to this organization so that they can cut down on their capital infrastructure costs by pulling TV services from somebody who's made a bigger investment in a head end and dividing the cost across lots of other customers. Classic cloud-based service model, but for cable TV in this case. And what they're doing is they're multicasting from the managed IPTV service provider. They're sending multicast streams of all the different cable TV streams into this head end, and then they drop it out on the network. And the way multicast works is there's a rule called reverse path forward. These devices on the right will not forward the multicast traffic, which is cable TV channels, into that head end router infrastructure out to the field if there is not a route pointing back to the source of the multicast stream. And so what they've done in this case is the default route on all these on this data center infrastructure points back to that managed IPTV service provider to make multicast work, because if it's not forwarding back in that direction, it will not route the traffic back into the head end. And so we're working this engagement, and we end up with access into the router, and we cannot. And we know there's all this infrastructure, and we're trying to scan, we're trying to go and do further recon against the network, and we're not getting anywhere. And we're looking at the ARP table on the router, and we see all these hosts. We see all these good targets. And we're looking up the MAC addresses, and we're seeing organizational IDs, looking at the MAC address, and know that there is a lot of server infrastructure that would be nice targets. But we can't get a two-way connection. And the reason being is these devices are pointing back north toward the managed service provider. So what we figured out, if you find yourself in a similar situation, what you can do, we discovered, is you just turn on NAT on the router where you have access. You can turn on NAT and do a static IP NAT translation based on what you're seeing in the ARP table, and give it IP addresses on the external interface. And then the router will proxy your connection for you. And then you can establish a two-way connection through the router to the devices sitting on the other side. Even though their default route is pointing the opposite direction, the router will proxy that connection for you because they're local. And then you can start popping boxes. So when we were out doing red teams, whenever we plug into the network, first thing I like to do is turn up a packet analyzer and see what's out there on the wire. If there's protocols out there on the wire, I've yet to see anyone doing authentication. If they do authentication, it's clear text. It's never MD5, whether it's a first hop redundancy protocol or a routing protocol. And typically, if there's a routing protocol, it's typically going to be OSPF or maybe EIGRP. But what you have I'll give you a quick overview for you guys that are not router guys with OSPF, is with OSPF, you have this concept of areas. With OSPF, you got to have an area 0, all the routers that are advertising routes. The network has to have an area 0, and then if you want to go, if you have a large network and you want to break it up into segments, you could have other areas, but the new areas have to touch area 0. So you could have area 1, area 2, area 3, what have you. And the routers that touch area 0 and the other new areas are called area border routers. And if you have a connection to the internet, that would be that router that touches up to the internet, or other routing protocols, say it could touch EIGRP or BGP, ISIS, etc. That is going to be your autonomous system border router, your ASBR. That's your crash course of OSPF. There's a link there if you want to learn more about OSPF protocol. But here's what I see that the red teams don't know, and they're not getting out of the hacking courses, and they're leaving low-hanging fruit I see during engagements. And I want to make sure you guys are aware of it and thinking about it, because the customers need to get this fixed. Because if you don't document it during your audit and your testing, and you leave this here, somebody is going to go and exploit it. If a redneck from Alabama is thinking about this, other people are thinking about it. And so, what can you do? You pull up, you bring up Wireshark on the LAN. You're seeing OSPF handshake happening. You're seeing a multicast, the OSPF multicast out on the wire, the hello packets. And let's say they're going to be no authentication or clear text, though MD5 is an option. I never see MD5. I never see it. So what can you do with it? Well, I have up in the right-hand corner is a box of tools reference that you could go check out. But here's some ideas for you. Why not go and add yourself to the network using, say, a Coggin router, go buy a router off eBay and fire it up in a GNS3 Dynamips. You could go and get the Naval Research Lab core tool, which is another simulator that uses Coggin, and join that network and start advertising routes. Why not go and start advertising the routes to, say, Google, Microsoft, some other interesting government agency, and start advertising those routes into the network and configure your device to be using one of those foreign IP networks. So when you're doing your pen test and audits, if they start looking at their logs, if they're using ArcSight or Splunk or what have you, they start looking at their logs and they see attacks happening, they're going to think it's coming from Google or Microsoft. And you're right there on the inside of their network, and their logs are filling up with all these other IP addresses. I mean, geez, they'll be thinking, you can make them think the CIA or NSA is coming after them, inside their network. They'll be chasing rabbits, and you're injecting routes for those organizations. You could do a man-in-the-middle attack. Of course, you could do a denial of service. You're limited by your creativity, and most specifically, since all you guys are ethical hackers, we're not no black hats here, right? It's going to be based on your rules of engagement. So every time I do a pen test, denial of service is always off the table. We just document how we would conduct a denial of service if it was inside the rules of engagement. But going and doing man-in-the-middle attacks, injecting new routes so that we can influence their logs and throw them off our tracks, that stuff is typically inside of our rules of engagement. You can go and look up all these tools on your own later. Attack that's in the news a whole lot here lately is BGP. Here's how BGP works. I'll give you a quick crash course on BGP. BGP organizations have an autonomous system number, If you're large enough to have multiple connections to the internet, to be multi-home to the internet, if you're in the U.S., you're going to go talk to Aaron. If you're in Europe, you're going to go talk to Ripe. If you're in Asia Pacific, you might go talk to Abnick to go get a AS number. And you would also have your own independent block of IP addresses to route up into the BGP network. And you might also, if you're a large enough organization with large enough number of BGP routers, you might break it up and use things like route reflectors and confederations to break up your BGP network to make it more manageable. But what I have on that bottom left there, want to call out to you, is you have aggregation points like data centers where lots of providers bring in their connections, and they do what we call a cross connect, where they interconnect with each other to send traffic between each other's networks in different data centers, central offices around the world. And typically what that is nothing but a really big layer 2, layer 3 switch, and everybody comes together and meets and does an Ethernet IP cross connection in those networks. And some of those central offices, some of them are very, very secure, where they got the guards, gates, and guns, cameras, very, very controlled, very, very, very strict security. But in some of them, you're wondering what in the world is going on. Fiber, copper wiring flowing out of racks all along the floor, numerous customers all stacked up on top of each other. It's hard to discern where one customer's infrastructure in a rack, in a 21-inch telco rack, where their stuff begins and ends. It looks like one of these pictures on Instagram of a worst nightmare of a network closet in a central office, and you've got everybody coming together in those networks. And so that made me start thinking, what could you do with that? What might someone do? Well, you have to imagine if you get into access into a central office data center where everybody's coming together and there is such bad operations management where they literally have just cabling just strung out along the floor, it's flowing. It's just a rat's nest. If they manage the physical operation that sloppily, in my experience, I've been in this business since '94. My experience is if it looks that bad physically, it's going to be even worse operationally in the configs. That's just the way it is. And so most likely you could get access, and plus you got physical access into the rooms. So what could you do at that macro layer when you get that access? Well, you could still go do all the layer 2 attacks probably that you would do in an enterprise pen test, like the ARP poisoning and things, and do denial of service. You could go and do route injection in those meet points where the telco service providers are coming together, or the cloud-based providers have their service offerings coming into those switches. You could inject routes. You could do the ER span type attack that I showed earlier. Maybe you go and pop the box and enable the L2TPv3, or go and that they got the SNMP version 3 code set so that they can support lawful intercept. So why not go and exploit that, possibly to exfil traffic? You're only limited by your imagination there. Now, this has been documented at a lot of conferences, but I wanted to bring it up because it's happening a lot still, and people are not looking for it. We're interesting organizations in the world or hijacking targets' IP prefixes and advertising it as their own. So you might have an organization, say Autonomous System 6, that talks to Autonomous System 4, and you have somebody over there that owns Autonomous System 5 somewhere interesting in the world. There's nothing to stop someone that has the control of a network from advertising your organization's IP prefix. And there ain't nothing to stop it. In the U.S., the telcos have very, very strict control. If you were to go multi-home and bring up a BGP connection in the U.S. with AT&T, Quest, etc., they're going to control and limit what you advertise up to them. They're going to verify with Aaron that you do own this autonomous system number, that you own this IP block, and they're going to very strictly control it. But the rest of the world, they got their own rules, and they'll do what they want to do. In some cases, the government is helping run these telco service provider networks. And so it's very easy for them to go and hijack an IP prefix. Now, at the same time, since organizations, if they can do an IP prefix hijack, they could also go and hijack your AAS number, like I showed down there in the bottom. They could also go and advertise that they own your AAS number, and make it look like your AAS number is being sourced from say that you have some kind of network connection into that part of the world, and source traffic back out into the internet to look like the IP prefix is originating from your AAS number, and you have a path that you have some kind of telecommunications infrastructure that is routed natively through their network. There's nothing to stop that. But here's something I'm working on a presentation now that I want to make you guys aware of. As I been thinking about this problem with the IP prefix hijacking, is I spent a lot of time building telcos, going from the ground up with building telecommunications providers, and we're building 100% IP networks. There's no analog digital except for at the customer prim. It's all IP. It's a pure IP infrastructure. And what we're able to do is we take these routers and we use MPLS, multi-protocol label services, to carve up the routing table and give different services a MPLS VPN, a virtual private network using MPLS, and also give customers private MPLS networks for like Metro Ethernet services or a wide area network type service. And at the same time, on that same router, we will be providing BGP services. What's very important to understand is whoever has the access to these routers that's executing these IP prefix attacks against BGP, they have access to the MPLS routers as well. And so if you're buying MPLS services and you're a national provider, I mean you got a company that's a international organization where you're dropping MPLS VPN circuits out around the world, I hope you're running encryption. If you're not running encryption across your MPLS networks, the same guy that's doing the BGP hijacking is probably hijacking your MPLS connection and you just don't know it. They may be just sniffing traffic, but so is confidentiality, privacy an issue for you? And at the same time, is it of interest to you that if they have that kind of access and they're doing this, what is to stop them from joining your IGP, your BGP or your IGP, your internal gateway protocol, say that you may be running across that MPLS network, you might be running OSPF, you might be doing BGP. What is to stop someone that has that level of access from going and participating in your internal routing that you think is totally private because you got a VPN? There's nothing to stop them from joining that, injecting new routes, exfilling traffic, routing your traffic around, and modifying and injecting new traffic. And some people will say, well, you can go and look at the latency and things like that, trace routes, et cetera. Well, if you're doing this inside of an MPLS cloud, we can turn off trace routing so you never see the router hops. You never know that you're crossing new routers. So things like that could also be happening through this access. Just want to throw that out to you to be thinking about it. I'm going to put a whole presentation together just on MPLS. I have no documentation. I have no information that this is happening. But if I'm the bad guy and I'm doing these attacks to you, I'm going after your MPLS networks as well. I think it's happening, and then what I would recommend from the MPLS VPN standpoint is you put the best encryption you can on your endpoints. And specifically, the threat is in the international networks where you leave the U.S. and you're going carrier to carrier inside the MPLS cloud. The other recommendation for the BGP is there's a website called BGPmon. Go out to bgpmon.net and you can put in your IP prefixes. They have a service they provide where they will go and monitor your IP prefixes and alert you when somebody hijacks your network. There ain't a whole lot you can do about it because but you can go and talk to the upstream providers and see if they will cooperate with you and work with you to try to stop it. but at least if it's happening, you know about it. And BGP-Mon will alert you to it. If you don't want to go and work with BGP-Mon, if you got some, if you're a really good scripter, you could go and look at the BGP Looking Glass servers out on the internet, and you might be able to code your own with Perl or Python and build your own application for going out and monitoring the BGP network to see what's happening with your IP prefixes. But a lot of people are not looking at this, and they think it's the other guy that's getting hijacked. But how do you know it's not you? Because if you're not looking, it could be happening. It may not be happening now, but it could have been happening in the past. You don't know what you don't know if you're not looking. So that's the talk I had today. You guys got any questions? Okay. Yeah. Only the BGP. I know the BGP is happening. The stuff I showed, nobody's thinking about it. It's not published. The L2TPv3, if you're doing attacks with L2TPv3 inbound, I've not seen documented. The IPv6 over DLSW, I've not seen documented anywhere. I've just made that up a while back. Doesn't mean somebody else is not doing it. I have not run into it, but I want to make you guys aware of it as red teams. That this is some things. Get out of the box. Don't limit yourself to say to what you learned in CEH or some of the other classes. Get out of the box and use these routers that you pop. Educate your customers on the network infrastructure, because everybody's focused on the endpoint devices. But when I participate in a team, I'm not the web guy. I'm not the Android, iPhone guy. I go after the network infrastructure, and we have been 100% successful over taking over everything by going after the network infrastructure, because nobody's looking at that. Everybody's putting in all their investment in the endpoint devices, and all we have to do is find that one handhold into the network infrastructure, and we own it all. I don't care what you're doing on those endpoints. If I get a hold of that network infrastructure, we own it all. All your passwords, everything. It is going to be a very, very ugly report when we get done. And if you're not looking at it as a red team, we're leaving a lot of holes. And I feel very passionate about this, because when I go in behind auditors, the auditors are very skilled maybe at Windows, maybe Unix, and they're going in and they collect router configs. They collect switch configs, but it's like nobody's looking at it. The auditors don't have skills in that area, and they're leaving that there. And if they don't bring in a pen test team that has network skills, it never gets remediated. And it's just laying there waiting for somebody to come and exploit. So if we're going to do a due diligence, we need to be going and properly assessing the network infrastructure. Because if I'm on the team, I'm coming after it. And, any more questions? Well, what I would prefer that you do is that you have, that's a really good question. I'm glad you brought this up. Why not go to solarwinds.net and download the Kiwi tools, the CAT tools, and have logging turned on and authentication turned on. And as soon as somebody logs in, you know who that user is that logged in. And as soon as they start hitting return, they go into config mode and they start hitting return and making config changes, you should get an email notification that somebody's modified your config. Those tools are cheap and they work. My customers, when I build a network, I put that in place. And if I log in later and I start making config changes, they're calling me. I saw you logged in my network and you're making config changes. Did we have that change scheduled? Is that a scheduled change? Was I in the loop? Is my team in the loop? And it's very cheap tools, so you should know it not a week later. And at the same time, in those same tools, as soon as a config change happens, you should be getting an archive. I mean, you don't have to wait a week. You can have this all automated. As soon as the config changes and it gets saved, you got an archive of it, and somebody's watching it and looking for the differences. Is that an authorized change? Was that planned? Was it an out-of-turn, unscheduled change? I mean, what happened there? But in most cases, nobody's looking for that. They don't look for it until after somebody's gone in and done a pen test and and tore the network apart. And then then it's part of the mitigation plan, the plan of action to mitigate all the findings. They go put these things in place. But it's really cheap and easy to do with the CAT tools from Kiwi that SolarWinds bought a few years ago. So that's a good question. Another good recommendation is if you're not doing NetFlow, get NetFlow. Get layer 2 and layer 3 NetFlow on the network so that you know what's normal. Get some instrumentation and benchmark, baseline your network to know what the traffic session flows are, what's normal, what's abnormal, who should be talking to who, when, where, and how much. And if somebody starts running some of these attacks against you, and you start seeing traffic flowing out of your network that's abnormal, you'd know about it because you've got a baseline. Any other questions? Okay, I appreciate you guys listening to my talk. Hope you got something out of it. Thank you.